Hello, my name is Joshua Lucas. This team is consisting of just me. I go to Issaquah High School and I am based in Washington in the United States. This is my completed challenge for tutorial 1, which is a blinking traffic light. What it does is that it turns on the red light, then turns it off, turns the yellow light, turns it off, and then same with the green with a delay in between each of them. Here is my completed tutorial 2. It sets up the input and the output, which is a push button and an LED. And then when the button is pressed, it makes the delay much shorter, which means that the LED blinks slowly until the button is pressed, where it blinks very quickly. Here's my completed tutorial 3. It sets up the serial.begin as 9600 and sets the 5th pin as an input for the push button. And then basically when the Boolean is true, meaning the button is pressed, makes the string high, otherwise it makes it low, and it'll keep on printing. So then when I push this button, it starts typing high. When I let go, it starts displaying low. This is my completed tutorial 4. The circuit basically turns on more lights as you rotate the potentiometer. How it works is that it reads the analog input of the rotation here, and then based on certain values, it'll turn on the different LEDs. So again, here's the demonstration. This is my completed tutorial 5. It makes the LED brighter as the potentiometer is turned. How it works is that it reads the rotation and puts that value into the analog right. So that means the LED gets brighter. This is my completed challenge for tutorial number 6. I have a circuit that will spin the fan if you turn up the potentiometer, and then if you hit a button and put it up again, it'll spin in the other direction. I did not have a switch, so I made an H-bridge, and this H-bridge uses the diagonal transistors in order to change which direction the current is flowing for the DC motor, and the button acts as a switch by checking the state of the button before and the state of the button when it's pressed, and based off that, it'll switch the spin state. And here's my code. This is my completed tutorial 8. It uses these pins as the outputs for the 7-segment display, and then it uses the digital read to see if the button has been pressed. If it is, then it resets the counter to 0, after which it'll take the modulus of the counter, and depending on that, it'll give a different display. Afterward, it'll have a delay and then set the display off, and then have another delay and increment the counter, which makes it count up like this. And then if I press this button, it'll reset the counter. This is my completed challenge 9. It uses an LCD to have a timer. So it increments the timer after a 100 millisecond delay. And then if the thing reaches 600 milliseconds or 60 seconds, it'll bring that back down to 0 and increment the minute. And it'll print that out on the display. And as you can see here, it is printing. And then if I hit this button right here, it'll reset to 0, and this potentiometer controls the brightness. This is my completed challenge 10, which makes a synthesizer for a piezo buzzer. It takes in the 8th pin as an output for the buzzer, and the analog 0 pin as an input for one of the potentiometers. And you can increase the volume like that, and you can change the pitch as well. This is my completed challenge number 13. The program simply senses when the temperature is greater than 100 and turns on the motor. So let me use a lighter here. It looks like it got to 100 itself. Turn it back on. And as you can see, its reading is 100. Sometimes the sensor doesn't work and it turns itself off.